Hello dear learners, you are welcome to yet another class of physics. In this class, we are going to demonstrate an experiment to determine relative density of a liquid using Archimedes' principle. My name is Biekwaso Semakula Samuel. I am a teacher of physics. In this experiment, we are going to determine the relative density of cooking oil. The apparatus that we are going to use, we are going to make use of this stone. We are going to have water in a beaker, and we are going to use a spring balance, which we are suspending on a retort stand. Step 1, we determine the weight of the stone in air, which is the actual weight of the stone. So we suspend the stone on the spring balance and we read the weight of the stone from the Newton side of the scale. Weight of the stone in air is 0.60 newtons. Step 2, we obtain the weight of this stone when it is fully immersed in water. So we have our water in the beaker. So we want to get the weight of the stone when it is fully immersed. So we gently lower the stone in the water. Make sure that it is not touching the sides, neither is it touching the bottom. It should be fully immersed without touching the sides or the bottom of the beaker. So we have our stone here, freely suspended and fully immersed in water. So we check the reading of the weight of this stone, which is also called the apparent weight of the stone when fully submerged in water, and this reading is 0.35 newtons. Step 3, after thoroughly drying the stone, we shall now get the weight of the stone when it is fully immersed in oil. So we bring our beaker of oil and we gently lower the stone into the oil. We gently lower the stone into the oil, making sure that it is fully submerged without touching the sides or the bottom of the beaker. Fully submerged without touching the bottom or the sides. So here we have our stone fully submerged in oil. So we take the reading of the weight of this stone when fully submerged in oil. And this weight is 0.40 newtons. So the weight of the stone when fully submerged in oil is 0.40 newtons. Now we have 3 readings. We have the weight of the stone in air, we have the weight of the stone when fully immersed in water, and the weight of the stone when fully submerged in oil. The relative density of oil is obtained from relative density is equal to upthrust in oil divided by upthrust in water. Now upthrust is weight in air minus weight in the liquid. That means that the upthrust in oil is equal to the weight of the stone in air minus the weight of the stone when fully submerged in oil. Then the upthrust in water is equal to the weight of the stone in air minus the weight of the stone when fully submerged in water. Now we realize that the upthrust in oil will be 0.20. That is 0.60 minus 0.40. Then the upthrust in water will be 0.25. That is 0.60 minus 0.35. Therefore, the relative density of oil is 0.20 divided by 0.25. And this gives us 0.8. The relative density of this oil that we have used is 0.8. Now, since we know that relative density is the ratio of density of the substance to the density of water, we can actually get the density of this oil. Because the density of the oil will be the relative density of oil times the density of water. Knowing that the density of water is 1 gram per cubic centimeter, that means that the density of this oil is 0.8 times 1, which is 0.8 grams per cubic centimeters. In SI units, it is 0.8 times 1,000, which will give us 800 kilograms per meter cubed.